Hi guys. This is the final presentation of 242. Today I will explain the workflow of our project, which focuses on optimizing Airbnb rental pricing, using historical data. Our goal is to provide hosts with insights to set fair and competitive prices. Next slide, please. We begin with data preprocessing, where we integrated data sets from New York City, New Jersey, and Albany, ensure diversity in the data. Afterwards, we clean the data by removing irrelevant columns and filling in missing values with different methods. Next, we move to feature engineering. For textual data, we apply NLP sentiment analysis to extract sentiment scores. For numerical and categorical data, we scaled and encoded them to ensure consistency for model training. To simplify our data set, we perform PCA. It helped reduce the dimensionality and focus on the most important features. Then we developed a baseline model, which provided a very basic a benchmark for comparing the performance of the advanced models. Our primary focus was on training XGBoost and random forest models, incorporating hyperparameter tuning and maximizing their predictive accuracy. Finally, we use visualization tools like SHAP to interpret the results and explain the impact of different variables on pricing. Okay, I will hand it over to my teammates.
Okay, so I will talk about the dataset. And our dataset includes those three CSV files we download from the Airbnb website. And for those integration of the three CSV file, we have a dimension that have more than 30,000 rows, which is listing. And we have 75 column, which is variable. And we decide our dependent variable are prices. Next, please. And here is our variables. You can see there are lots of variables, so we must remove some irrelevant variables. Next slide, please. So our initial deletion is by intuition, and we will delete some variable like the name, which is like the name, the ID, which is intuitively nothing to do with our price. And also we drop the rows which have no prices, which means those rows are useless for our prediction. Okay.
Now we move on to the processing of missing values and the standardization of special columns. For the missing room types, we adopted the KM methods to fill in the missing values with the data from 5 nearest neighbors, and we replaced the NA values for review columns with the median. Next slide, please. And for some of the columns that have special formats, we standardize them and also use median to fill out the missing values. For categorical columns, we replace NA values with mode instead. And next slide, please. For textual columns that are hard to quantify, such as the customer reviews and the host description, we apply NLP methods to do sentiment analysis. We clean out the text input, tokenize it, and remove stop words and calculate the compound sentiment score.
So currently, so far we have built 2 models for training. First one is a baseline model, which is a linear regression model, and the performance is we have 0.14 in MSE and 0.18 in R-square. And then we build a XGBoost model here, tuned by randomized search CV method, and we reach a MSE as 0.08 and a 0.51 R-square, which is a huge improvement, but well, obviously not enough. So in the future, we will try PCA and see if there's any improvement in the model performance, and we will try to build random forest or like any other models we want to build and make comparisons to try to like get a higher performance in our model. And also we will try other potential feature engineering methods like stacking to integrate multiple models together. Yeah, that's basically all, and thank you very much for listening.